Hi everyone, welcome back to my channel. Today we are diving into how large language models approach solving math problems. These models have certain computational limitation that make problem structuring crucial. Let's explore how they process and generate the mathematical reasoning, right? So let's first start with understanding the LLM computation, right? So when LLM are solving the problem, they process information by token in a linear sequence, right, from left to right, as you can see in this diagram. So essentially it is processing, the model is processing the each token from left to right in the sequence. And in this example, right, I'm using the example of nano GPT. So it will go through these three layers, right? So essentially that means actually the model have a finite amount of computation, and then before model moves to the next token, right, that means model have to distribute their reasoning across the multiple token to provide a accurate answer, right? So if you ask model to immediately output the answer in single token, right, you are essentially forcing model to make a guess without proper reasoning. This can lead the inconsistent or incorrect answer, right? So essentially we have to, whenever we are asking model, right, we should not ask like that provide answer immediately, right? Then in that case model will not get time to think, or it will not create an intermediate steps chain of thoughts, and then the answer might be wrong, right? So we will talk more about this in the second section. So this is why the structuring prompt matters, right? So when we structure the prompt for either for post training or for the inferencing, it matters, right, how we structure the problem, right? And I will show you the example here, right? So basically so we have the two version of prompt for the same problem, okay, and those are structured differently, right? One asks for the immediate answer, other asks for the other to break down, right? So let me go here and let me open the new instance of chat GPT, and let me just go ahead and ask this question, this prompt here, right? So basically we are asking model chat GPT to solve this math problem, right? And in this actually we are instructing model to answer a question in single token and immediately and just give me the answer, nothing else, right? Okay, so model answered this question. It did not think through. There are no intermediate steps, and this answer is not accurate, right? So basically, what happened here is model guessed this answer. Okay, it did not apply any kind of reasoning, something like that, right? So now let me ask model that don't worry about the token, and then use as much as token, right? So now since we are giving a liberty to model that use as many as token, so what it will do is it will essentially will break down this problem, right? And then it will create a intermediate steps, and then each intermediate steps as a token will go to the in the model, and then it will answer the accurately. So as you can see here, now it broke down this in the steps, and then it provided the correct answer, which is $4, right? So now the next thing is, let's say we don't trust on the model, right? Because model is also using, it is like a brain, right? So what we can do is we can ask model to write a code, and these models are very good in copying the information, right? So from the prompt it will copy all the key information in the code, and then there will be another compute source which will run that code, and it will provide the answer, right? So let me go and ask use code. So now it wrote the code and it copied all the information from that prompt, and then it answered, right? So this is how this is the another way we can get the accurate answer, right? So now let me go back to my next step here. Okay, so now the next thing is actually training the model, right? Especially the post training, which we normally do using the supervised fine tuning, right? Where we train the model to understand how to answer the question, right? Because initially when the model is pre-trained, it doesn't know how to answer the question, right? So basically, and this is very important, right? If you provide the incorrect or misleading example, then model will learn incorrect pattern, and then that's why the labeling training data properly is critical, right? So if we emphasize step by step reasoning rather than just a correct answer, the model perform better, right? And this is the one of the example, right? So here we have the question prompt, and these are the label, these are the answer, right? And as you see here, both is providing answer 3 3, right? Both answers are 3, right? Both answers are correct, right? But for the model perspective, this is the better label. The reason is, here first what we are providing here is, we are providing model to first think through, we are providing step by step, right? And then finally we are providing the answer, right? And here what we are doing, we are providing the first answer, then step by step the breakdown, right? So in this case, when we provide a first answer, what model will do is, it will, if it is a complex problem, right, it will just guess, right? Because it has a certain or fixed amount of compute, right, for each token, right? So it might not able to accurately calculate and then post that actually, because it will not do the reasoning, right? It will just create some kind of steps here, right? But in this label or in this answer, right, since we are providing the breakdown or step by step intermediate step, so first it will do the reasoning and then it will answer, right? So 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 what did you learn in this, right? So essentially we learned that LLM solve problem token by token, meaning structured reasoning is essential. If you want better math perform from the an LLM, guide it through the reasoning process instead of forcing an immediate answer, right? If you found this helpful, don't forget to like and share and subscribe for more AI insights. See you in the next video.